So here is another question. So it is given that the position of a stone dropped from the top of a cliff, mountain cliff, it is given by the expression x is equal to 5t square, where x, the unit of x, the position or displacement is meters, and t is in seconds. What is the acceleration of the stone at t equals to 2 seconds? So this question, it is based on the concept of instantaneous velocity and acceleration. Okay, so here position or displacement, that is given by x is equal to 5t square. Now instantaneous velocity, it is given by v is equal to dx by dt, which is equal to d by dt 5t square, which is equal to 10t meters per second. This is meters, this is meters, this is 10t meter per second. Then instantaneous acceleration A is equal to dv by dt, rate of change of velocity, that is equal to d by dt of 10t, which is equal to 10 meters per second square. So here if you see, instantaneous acceleration is independent of time. There is no such thing as t here in this expression of instantaneous acceleration. So no matter what the time is, the instantaneous acceleration is always 10 meters per second square. But the instantaneous velocity, it is dependent on time because of this t part here. So it will change with time, but here there is no t in expression. So there will always be, the instantaneous acceleration, it will be constant. Okay, so here the acceleration of the stone at t equals to 2 seconds or any such time, it is 10 meters per second square. Okay. So here is another question. So it is given that the position of a particle is given by the expression x is equal to kt cube, where k is a constant. We have to find the velocity and acceleration of the particle as a function of time, t. Okay, so again it is based on the concept of instantaneous velocity and acceleration. So here the position, the displacement, it is given by the expression x is equal to kt cube, where k is a constant. So velocity, instantaneous velocity, it is given by dx by dt, derivative of displacement or position with respect to time, equal to d by dt of kt cube. Okay, so that is equal to 3 kt square. Okay, that is the velocity. Then acceleration is equal to rate of change of velocity with respect to time, dv by dt, is equal to d by dt of 3 kt square. Okay, 3 kt square, which is equal to 6 kt So here it is meters per second units, here it is meter per second square. This is the acceleration. Okay, so here for this function of which is used to express the position or displacement, velocity is expressed as 3k t square meter per second, and acceleration is expressed as 6 kt meters per second square. This. Okay, so another way you can directly calculate acceleration, that is also we have discussed double derivative of this, which is same as dv by dt, because v is equal to dx by dt. Okay, that way also you will get the same result. Okay, so here is another question. Again, here the position of a particle moving along a straight line, it is given by the expression x is equal to 2 minus 5t plus 6t square. We have to find out the acceleration of the particle at t equals to 2 seconds. So again, this question is based on the concept of instantaneous velocity and acceleration. Here the position, displacement, whatever you call it, along the straight line, it is given by the expression x is equal to 2 minus 5t plus 6t square. Velocity, instantaneous velocity, that will be given by the rate of change of displacement, the derivative of displacement with respect to time, which is equal to minus 5 plus 12t. Okay, this is in meters, this will be in meters per second, minus 5 plus 12t. Okay, then acceleration or instantaneous acceleration, that will be rate of change of velocity with respect to time, derivative of velocity with respect to time, which is equal to 12 units meters per second squared. So again you see in the expression of acceleration here, this is independent of time. The expression for acceleration, it is independent of time. There is no t, coefficient t attached with it. So here instantaneous acceleration is independent of time. So it will always be plus 12 meter per second square at any point of time. Okay, so this is the expression or the value of instantaneous acceleration. So no matter what the time is, whether it is 1 second, 2 second, 3 second, whatever it is, it will be this much. So according to the question, to find the acceleration of the particle at t equals to 2 seconds, it will be 12 meters per second square. Be same. Okay.